This is the introduction to Sprint 1 of the Taco prototype work cycle. The team for this work cycle is Christina Harlow as Data Ops, Aaron Fahey as what is it?
Ops liaison and DevOps.
DevOps. I'm like, which ops?
All the ops.
Aaron Fahey as DevOps, Justin Coyne as developer, myself, Aaron Collier as tech lead and developer, Ben and Hannah as shared product owners, and Vivian as direct liaison. This was a 1-week sprint, and so the goals for this week were to come to a shared agreement and understanding of our architecture, clarify how we will approach testing in a new development environment, how local development will happen in a new development environment, some very important questions surrounding dependency management, code architecture, and coding practices within a new development architecture. Using a fake or a stub backend for the AWS API that works locally for development, and getting the initial deployment of Taco to AWS.
Mm-hmm. Great. Okay. Thanks, Aaron. So I'm Christina. I'm data ops engineer at DLSS, and I'm going to walk through some of our expanded documentation. As this is a prototype work cycle, we have been trying to stay very consistent with documenting all of our different changes and practices for the sake of being able to report back out to our department as well as our communities that we interact with. On our Taco GitHub repository, you can go to our wiki. This is mainly the source of where we're trying to keep the documentation for this work cycle. I want to point out that we have added a couple different, some new documentation since the last sprint. We have put in, first of all, some of our system and design overviews and approaches. We have our initial design. This was provided to us from the SDR3 design group, SDR3 being part of the evolutionary process around us and Taco being a part of that. We've mostly fulfilled this design so far, so it's good to have there to compare with and check ourselves based off of our peers and our larger design group's efforts. We continue to publish, as we showed last time, our current API spec at this Swagger endpoint. This is hosted directly from the swagger.json file in our GitHub repository's master branch, so it's always up to date according to what is running. I don't know if there's a couple small things we can show that we've added. There's been some changes to how we just define some of our specifications in the API to make it a little bit more easier for people to read and understand what we're talking about when we say deposit a new resource or update an existing resource. We've added expanded samples, and as part of that, an expanded data models for resources going in and out. This is part of our defined or iterative effort of having our data models for a repository really grow first based off of processing need, and then second, be extensible as we liaise with our metadata department in future work cycles to expand it for descriptive and other practices. We know that metadata changes quite often, so having this process early on actually helps us test that we know we can iterate and expand a data model as we go along. So you'll see that we've expanded the model for our API and put in more information about some processing requirements, such as whether or not the object should be preserved or published, what sort of access levels it should apply to. I would also show we have added a status route. I can't remember if this was here the last work cycle or not, but this is us stubbing out a way to say, I have this resource, can you tell me where it is in the processing framework that will be happening asynchronously below this API? So we know that we have to have a reporting state there, and so we've added this. We've added a health check, which we'll see later, just to be able to stub out some needs for our deployment purposes. And I would also mention we've tried to add more explicit exception responses. So before we just had 200 okay for most of them. We've switched some of the 200s to 200s and 201s, given that we are creating resources in some of these, and tried to expand other routes for failed requests. That said, so that's the state of our API. You can always check it out at that link. We have some sequence diagrams that I have not added yet, but I can pull an example from here. These are created by Justin. These are really helpful to show how we expect that our API will interact with messaging with components underneath our API. I'm hoping to get these expanded into our wiki soon, but these are very helpful to go through as well. And they just clarify that the team is all on the same point when we're talking about this architecture, which can actually be a little bit tricky to confirm that sometimes. So those are being added. And then we have a very loose evolving design, which we can talk about later. We've primarily been working on this part, the interaction of clients through this low-level Taco API to our Docker container, which will eventually and is now deployed to Elastic Container Service in AWS. And what we've been working through architecturally is what the processing underneath of that will look like, as well as what relates how to our persistence layers. We can get into that more detail, but this is all on our wiki. So that's the updated documentation so far. The other thing I wanted to call out is as we get further along on stubbing out this API interface to Taco, we have begun to do analysis on what our processing needs to look like. This was based originally on our existing processing framework, blah, 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 blah. So going through our current framework and really reviewing it for what steps happen, and then doing analysis of, at least for this first pass of a prototype, what steps should we pull over, or what kind of functions should be represented. This is a preliminary overview, and we're hoping that this will lead into what our tech team deep dives on next week or the week after. So taking those steps, we've started to write those up into not just information on what actions should occur at a high level, separate from system concerns at each request route. This is beyond just being able to pass in JSON and getting something back. This is beyond the API specification to knowing we should check permissions, we should check for these fields, we should give it an identifier, we should have it checked for structural metadata validation, we should derive descriptive metadata. And that has been, we've begun to try to map that to our processing selection. So more on that next week, but this analysis was started this week, so that's great. So that's expanded Wikidocs. We saw the expanded Swagger API, and we saw the processing framework start. Now we want to look at some of the Go code that has actually been written, and Justin Coyne will be walking us through that.
Hello, this is Justin Coyne. I'm an engineer, and I'm working on this Taco sprint. First, we're going to start by showing how we start up our local stack, which is a clone of the AWS framework that we're going to be using in production. And I'd run that by calling services and saying the services we're going to depend on, DynamoDB, Kinesis, and S3, and we can start it up. It takes just a few moments to get these services started. Then we can go ahead and start up our Taco app API server. It starts up, it lists all the environment variables that were set, or the things that it defaulted to. And then we can go ahead and start throwing requests at it. So I wrote up a script that we can use. Oops. And I realized that we've forgotten to initialize some of the dependencies. We need to create our tables, our bucket, and our Kinesis stream. So we'll go do that. So now we've created a DynamoDB table, an S3 bucket, and a Kinesis stream. And now if we go to the web, now you can see that we've allocated these resources and we're ready to start using it. All right, the first thing we're going to do is create a resource. This is going to be a metadata resource. So I'm doing a post request with a content type of JSON, and I'm posting an example that we have in our Git repository that you can look at on the web, posting it to the resource create route and going to give it some pretty printing. So there's our request. It gave us a 201. It says it created it, and this is the ID that it got assigned. So now that we have that ID, we're free to look it up and see what got created. We do this by doing a GET request, again with the content type of JSON, and we're just appending the ID that it gave us. And here's what our resource looks like. You can see we've added this at context and at type, and this is an SDR3 object. Not too much information here right now. We just have a label and a few of the required fields set. Now we're going to go ahead and upload a file. In this case, we're uploading the README from a repository. And you can see it gives us much the same response as if we created a resource. And I guess we can go ahead and look at that. Oh. And I'll pretty print it. So now you can see that it gave us a type this time of SDR3 file rather than previously where we had SDR3 object. Right now we don't have a way to download this file out. We'll add that soon, but you can see in the log that it says the location of the file is located here in S3, in our S3 bucket that we've created. And one of them, we've got Honey Badger working. So now if we have any errors, we can see that they're added up here to Honey Badger, and anyone who cares about these alerts can subscribe to them and they'll be notified. And then our final thing to demo is that Aaron has this deployed to ECS in Amazon. So we're actually going to hit the live cloud right here, and we hit our health check endpoint. And you can see that the service is up and deployed. And we've yet to hook up all these external services like Dynamo and S3 to that. So we haven't demoed there other than just this health check endpoint. And that's it.
Great, thanks, Justin. Okay, go ahead and stop sharing your screen. Thank you. Aaron, is there anything else that you want to walk through with the ECS deploy?
I think when we get the external ones, like I said, I can refine that systems diagram and do that next time.
Okay.
Is that okay with everyone?
Yeah, that's fine.
Okay.
So let me go back to this. All right, so we've seen our expanded documentation. We've seen our expanded API work. Thank you, Justin, for showing us how our Go code for the Taco API is now running, and we're using local stack in order to stub out for local development. But even more importantly, we know that it's now shippable to ECS and is running in ECS. We saw earlier the start of an AWS-based systems diagram for our application and our systems as it start to evolve and expand. We're hoping next work cycle we'll be getting a little bit further on the actual internal processing steps that were reviewed, as well as getting some of those other AWS services hooked up for deployment as well. So getting S3 created and connected in the cloud, getting Dynamo connected in the cloud. Other than that, thank you for watching the Sprint demo, and please either leave comments or questions in the YouTube comments area, or leave comments or questions, issues on our repository in GitHub, and we'd be happy to try to respond. Thanks.